Hi, my name is Justin Garrett, and I will be showcasing my code for Module 2 to display inheritance and polymorphism. This code is designed to compare electric vehicles and diesel vehicles. It compares the cost per trip depending on which type of vehicle you choose. Afterwards, it takes into account the vehicle getting maintenance and what type of maintenance the vehicle gets. After taking into account the maintenance, the code then updates the vehicle's new efficiency and health after driving a certain amount of miles. So the category I chose is vehicles because it's a good real world fit for inheritance and polymorphism. Of course, uh, I'm able to set a parent class, which is vehicles, and then two children classes, which are diesel and electric cars. I'm able to create multiple objects because there are multiple different kind of vehicles in the electric car field and the diesel truck field. So it was good to show inheritance and polymorphism as well throughout this code. As you know, I picked this because diesel and electric cars are known to be two opposite ends of the spectrum. A diesel vehicle is seen as less efficient or inefficient in today's day and age, and the electric car is shown as being efficient in today's day and age. So I made this code. I came up with the idea to compare the two, and I also really enjoy cars, so it was something that kind of worked hand in hand for me. I chose vehicles, and of course, implemented it into my coding journey. So I'm pretty happy with this code turned out, with how this code turned out. So today I'm gonna walk you through it. I have an interface which is serviceable, and it's declaring two methods, and they're all implementers and they must override. A parent class, which is vehicles, implementing the interface. I have three attributes: a constructor, getters and setters, and two custom methods using user input. I have an estimated trip cost, which does arithmetic based on user input. I have the service perform service, which modifies the object state using the input. So it actually modifies the trip cost and the efficiency of the vehicle after service is performed. I use the toString to override. I have two child classes, electric car, diesel truck, overriding parent behavior from the class vehicle. I used override toString, and then I have estimated trip cost and perform service. I have a main application which created 5+ objects, which is all different cars: a Nissan Leaf, a Hyundai Ioniq, a Tesla Model 3, and a diesel Ram 3500, a diesel Ford also. I have loops over the array. It prints info, calls overridden methods via the parent type, and demonstrates runtime polymorphism. So of course, I'm going to start with the vehicle parent class. So here I have the class vehicle. It implements the serviceable right here. It has attributes shared by all vehicles, which is a make, year, and mileage, a string, an integer, and a double. I have constructs. It's a vehicle with shared attributes. Sorry. So again, I'm passing a string, an integer, and a double through this class vehicle. Now here are my getters and setters for my make, for my year, and for my mileage. Here, it was going to return the efficiency of the vehicle in miles per energy unit, which is gallon or kilowatts. The children override this to supply their specific efficiency unit and value, and return a double in miles per unit. The default value is conservative, of course. Here is the get miles per unit. It's a default baseline. It's a subclass which should override with a meaningful value, and it should return 25. Here I have the estimated trip cost, which has user input, a print statement, which you would enter your trip in miles, and then you'll enter your price per energy unit, whether you're using diesel or electric fuel. Here I have the math for the units needed, which is the miles divided by the efficiency. So you'll take miles and divide it by the get miles per energy unit. And then for the cost, it's going to be the units needed times the price per unit, of course. So I have a division and a multiplication here. So if miles is large or efficiency is small, units needed increases, thus the cost increases, and it will return the cost. So now here is the perform service. So I enter the input statement for the user to input the miles to add after their service or test drives. Here's the math to calculate how many miles would be increased when you add it to your new service. Obviously, I put it in a input or print statement that miles cannot be negative if somebody were to try to put in negative miles. And when you do add miles to the vehicle, it will print vehicle has been serviced, mileage is now blank, plus the new mileage. Okay, and that is my class for my parent class for vehicle. Now let's move on to the child classes. I will go to the diesel truck first. So here is the class for diesel truck. It is a class for all the diesel trucks. So it has the double for the efficiency miles per gallon. Here it's gonna, has another double for the payload tons. Here I'm passing through the make, the year, and the mileage. Again, it has the same parameters as the parent class vehicle, same arguments. So for this, it's gonna show the efficiency and the miles per gallon, and it's also gonna take into account the payload tons of the diesel truck. So here it's gonna return the efficiency, and then it's going to, again, return the payload in tons. So now it's going to calculate the miles per energy unit. So when it has to take into account the payload tons, it has to take 1 and subtract 0.05 times the payload tons. And so it will create a reduction. And it's going to return the efficiency multiplied by whatever the reduction is, which is the weight added from the tons. Here is the estimated trip cost. Again, you're going to enter your trip in miles. Then you're going to enter your diesel and price per gallon, and it's going to ask if it's mostly highway or local driving. So depending on whether or not it's highway or not, it will affect the efficiency of the vehicle. And here I put in a slight comment that the highway improves mile per gallon by 10% in this simple model. So it calculates the effective miles per gallon. You take the get miles per energy unit, multiply it by the highway, which highway equals 1. So now the gallons needed would be the miles divided by the effective miles per gallon, and it's going to return gallons needed times the price per gallon to get your cost. Here, this is for the performative service of the diesel truck. You enter the new payload in tons, which how many tons your payload will be in your diesel truck. And then afterwards, it's going to ask you the type of service you did, if you replaced the air filter, and you'll say yes or no. And then it'll print out air filter replace, and then your new miles per gallon. And then you'll enter your miles after driven after service, and then it will return your new mileage. And overall, here's the string to return all of that, the effective miles per gallon, the payload tons for the diesel. Now we're going to move on to the electric car class. Here is going to be the efficiencies per kilowatt. It's the same thing like the diesel truck, but just now we're using electricity, and we're going to be using battery health percent. Again, it has the same arguments as the parent class vehicle, string for make, integer for year, and a double for the mileage. And here we have the effective miles per kilowatt, the double battery health percentage. Again, it's going to pass through the make, year, and mileage. Now for the electric vehicle, the energy unit is kilowatts, so it's going to return your miles per kilowatt that you drove, and the battery health can slightly affect real world efficiency and a apply a small factor. So here for the health factor, I'm taking 0.7 and the battery health percent and dividing it by 100 to help avoid, unrealistic drops in battery, percentage. So it's going to return the efficiency. So it's going to multiply the efficiency and miles per kilowatt times the health factor and give you an overall battery health percentage on how your car is doing. Now for the estimated trip cost, you're going to enter your distance in miles, same like the diesel, but you're going to actually enter your electricity price per kilowatt in dollars. So it won't be your cost per gallon, it'll be your cost per electricity. And then, like the diesel truck, it's going to ask you a question if you're going to be using fast charging on this trip, as when the diesel, we asked if we were going to be traveling on the highway or not. So for this one, the parameter would be, will you using fast charging on this trip? So for the units needed, you're going to take the miles and divide it by the get miles per energy unit to find the kilowatts needed to travel. And then for your base cost, you're going to take the units needed and multiply it by the price per kilowatt. So here I have a conditional at a flat fast charging access fee if selected. So the fast charge fee, if you're using um, fast charging, it's obviously you pay more to charge your car. Those who do have electric vehicles, the faster you do need to charge your car. Some places do implement a upcharge. So I set mine at $5 extra. So it's going to return your base cost of what you paid or what the user inputted, and it's going to add that $5 fast charge fee. Here for the performative service, the user can choose if it's a software update or a battery conditioning. So depending on which one you choose, it adds either efficiency or health to your electric vehicle. So if your choice is one, if you choose to do a software update, um, this is the math for the effective miles per kilowatt. Here for the math, the software will be updated and your new efficiency will be outputted. And then I have a if statement, an elif statement. Here, whether or not you choose one or two, it will depend on if it shows your efficiency or your battery health. And then if something else happens, which obviously depending on what the user inputs, it would say user service unknown and no changes applied. So optionally, you can add post-service miles as in the parent behavior, same thing. So you can enter your miles driven after the service, and it will set your mileage and add the miles you occurred after service. And then I have a string to print it all out. Here's the public interface for serviceable. It prompts the user for service details and applies the changes to the aspect of the car. Now this is the class for fleet app, which it shows every electric. I instantiated multiple child objects, and I created an electric car, which is a Tesla Model 3. I created another electric car, which is a Nissan Leaf, another electric car, which is a Hyundai Ioniq, and a diesel truck, which is a Ford F-250. Another diesel truck, which is a Ram 3500. And so this is how I created the fleet of cars, which are my objects that will be passed through the main application. So here we're going to go to the main application for this code. So again, it's going to pass my class here for vehicle, the parent class, with the string make, year, and mileage. So the integer for the year, the double for the mileage, and the string for the make. It's going to have my getters and setters for the make, year, and mileage again. Again, here we have the estimated trip cost, our perform service here, and then you have a string that returns and places it all together. So now let me run the code for you, showing you how it works. So here, it's going to be your trip cost estimate. So first we're going to start with each vehicle. We're going to start with the Tesla Model 3. I'll input 12. My cost for electricity, let's just say $2. And yes, we'll be using fast charging. Let's put for the Nissan Leaf 12. Let's put $3 and no. Now here we have the Hyundai Ioniq. Let's put 15 miles and let's put $3. Will I be using it? No. See, and here it shows the estimated trip cost for the electric vehicles. Now let's move on to the diesel. Here it shows the efficiency, which is your miles per gallon, your payload, and the mileage on the vehicle. So let's see, our trip be 34. Diesel price $4. Highway, yes. And that's our estimated cost for trip. Let's do 12 miles here. Diesel costs $4. And mostly highway, no. And see, your estimated trip cost is $2.98 here. So as you see, it's actually pretty expensive when it comes to the electric charging, but when it comes to diesel, the trip cost is looking a little bit lower. But now let's take into account efficiency here and performative service. So for the electric vehicle, let's choose, for the Tesla Model 3, I'll do a software update. And the miles I drove after the last service test, let's do 20. And so here, it do a per service update. It'll show the efficiency, the updated efficiency, your battery percentage, and the mileage on the vehicle. Now for the Nissan Leaf, I'm going to choose a battery conditioning. And I'm going to choose the miles driven after the service test will be 25. And here again, we have the efficiency, battery percentage, and the new mileage of the vehicle. So now let's do the Hyundai Ioniq. Let's do a software update. The miles driven after test will be 25, and all the updated stats are here. So now for the Ford, we're going to enter our payload in tons. Let's do 2 tons, because obviously it's a regular truck, you can't haul that much. Did we replace the air filter? No. And the miles driven after test, let's do high, let's do 45. Now the post-service stats, the efficiency, it'll be 18.5 miles per gallon, a payload of 2 tons, and your updated miles. So now this is the stats before, and now let's do after. A new payload. Yes, I replaced the air filter. So now it has new miles per gallon, updated it to 17.72. And then the miles driven after, let's do 45, because diesel vehicles tend to go further. And as you can see, the fuel efficiency for the Ram here is 17.72 with a new 2-ton payload, and the amount of mileages that are updated. And that would be the end of the code. So yeah, this code was actually something that really interested me. I really enjoyed coding something like this because it actually applies to a personal hobby of mine. So I hope you enjoyed, and hope it was good code. Thank you.